Hi everybody and welcome. Today we're going to be talking about specific types of triangles, and that specific type of triangle is actually an isosceles triangle. So for isosceles triangles and our learning about them, we're going to learn some of their unique properties, and those properties are going to allow us to solve for quantities and unknowns when we see specifically an isosceles triangle. So isosceles triangle, definition, refresher here, a triangle with at least two sides that are congruent. So in this case, see each of these individual dashes, they're telling us that those two sides are congruent. The angle formed by the congruent sides is called the vertex. So what that means is it is in between the congruent sides. So specifically, the only angle that works for that is right there. The two angles formed by the base in one of the congruent sides are called the base angles. So the base is the side that is not congruent, and the two angles that touch that base are the base angles. So again, base angle 1, base angle 2. So we have two different types of angles in an isosceles triangle, a base angle or a vertex. Vertex is in between those two sides. Base angles are basically the ones that touch or are next to the base. So using all these things together, we have a theorem, and it says that if two sides of a triangle are congruent, then the angles opposite those sides are also congruent. So our example is off to the side here. We have two sides that are congruent, so what it tells us is the angles that are directly across from those sides, so angles A and angles C, we can also say with certainty that those angles are also congruent. So labeling this triangle using our vocab, B is our vertex, and A and C are both base angles. So that is how we can distinguish the parts of an isosceles triangle. So starting from here, we can move forward into some further information, and that is a second theorem here, which is that if two angles of a triangle are congruent, then the sides opposite of those angles are congruent. You're like, Mr., did you just say the same thing twice? And no, I didn't. This time, we start with the angles, and it tells us that if the angles are congruent, then we can work backwards. We can say the sides across from those angles are congruent. So in this case, if you ever see that is the case, two angles that are the same, you can also say the sides are the same. If you see two sides are the same, you can work backwards and say, well, okay, the angles are also the same. So once more, we have our vertex, we have our base, then we have our base angles in our isosceles triangle here. So they let you work back and forth between angles and sides and all those different things. All right, so taking a look at example number 2, this allows us to work through and see some similarities here. So if we kind of break these down into two separate triangles, so we have a triangle on this side, we'll call it triangle number 1, and triangle number 2 on this side. Well, triangle number 2 has two sides that are congruent, so what that means is the angles that are across from these congruent sides are also congruent. So we can say that when we look at this on the side here, angle MLN is congruent to angle MNL. So MLN, this angle here, is congruent to MNL, this angle here. And then the second piece, they give us the other two angles that are congruent. So PLM is congruent to PML. So PLM, PML. They gave us little dashes already. And they gave us some congruent side lengths here. So ML and MN are congruent. But we can also say that because these two angles here are congruent, that this side and this side are also congruent. So kind of cleaning all of this up here, we have some additional measures. So we can also say that PM and PL are congruent. So that's the kind of the power of the theorem that we're working through here, is it lets us, based off of just having two things that are the same, we can go ahead and label all the other things that are across from those two things that are the same on the triangle. So congruent side, say hello to congruent angle. Congruent side, say hello to congruent angle, and vice versa. So what we can keep working through here is more theorems with triangles, and more things that we can draw from this is that a triangle is equilateral if and only if it is equiangular. What that means is because sides and angles match, there's no way that we can have a triangle with 3 sides that are the same if it doesn't have 3 angles that are the same, because the same side matches the same angle. So a little bit confusing on that one, but basically what it's saying is if you have 3 same angles, you have 3 same sides, and vice versa. So the flip side of this is each angle of an equilateral triangle measures 60 degrees. So if you have sides that are the same, the only way that we can do that is if we take 180 and we split it into 3 equal parts for the 3 equal angles, and that gets us 60 for each of those. Because there's 180 degrees in a triangle, it's the only way that that can work is if basically they all add up to 180, and it has to be 60 for that to be true. So for example number 3, they say that EFG is equilateral. So EFG, this big triangle on the outside, so all 3 of these sides are the same. So that tells us that we have 60-degree angles in our corners here. They also tell us that EH, so this line right here, bisects E, so it cuts it in half. So we know that E is equal to 60 degrees because it's an equilateral triangle. So if it cuts it in half, we can divide that by 2. That means each of the pieces next to it is 30. So 30 degrees here and 30 degrees here. So angle 1 and angle 2, because it's cut in half, those are each equal to 30 degrees. Lastly, it wants us to solve for x. So we can take our triangle, that we know that we have 30 degrees, we know that we have 60 degrees, and lastly we have 15x. So we can take all of these things and set them up in terms of our triangle. So they're all equal to 180. The 3 things we have are 30, 60, and 15x. So any like terms, we want to put those together. So 30 and 60 gets us 90. Again, more like terms, 90. Let's move it to the other side. So 15x equals 180 minus 90, which is just 90. And then lastly, divide both sides by 15. And we'll get an answer of x equals 6. So basically all that this is doing today is just a big game of matching. If you have equal angles, they have to match the equal sides that are across from them. As long as we do that, we're in good shape and we're able to solve for unknowns, just like we did on our bottom examples here. As always, if you got questions, let me know, but thanks.